Hello, my name is Mike McLaughlin, and I'm with the Technical Marketing Group at Nimble Storage. And today we're going to look at Nimble Storage with VMware in the modern data center. The agenda for today's presentation will cover a little background on Nimble Storage itself, the technology behind the product, the Castle architecture. We'll look at Nimble Storage with VMware. More specifically, we'll dig into VMware View VDI configurations with Nimble Storage. We'll then take a moment and do a quick product demonstration, and then we'll wrap up this presentation with a high-level review. Let's take a quick look at Nimble Storage. Founded in 2008, Nimble Storage began shipping product mid-year 2010. With about 2 years of shipping product, we now have well over 450 customers and over 1,000 systems deployed. Strong alliances with VMware, Microsoft, and Cisco, to name a few, as well as a strong partner channel, gives us a very good position in the storage marketplace. Our founders came from a background of storage and file system development at companies such as NetApp and Data Domain, and bring a wealth of storage expertise with them. Nimble Storage was founded on the premise of bringing flash technology to the storage marketplace. A quick survey of storage users in the market today, you'll find that many of them that are using flash-enabled storage of some sort are finding it very effective in addressing their needs. However, they're also finding that flash storage is too expensive relative to the traditional hard disks, and the drive capacity is not meeting the demands of the modern data center. The maturity of that market is also slowly evolving. So what we have here is basically a trade-off of new flash technology and existing spinning disk technology. The flash technology bringing to the market very high performance. Random IOPS from flash storage 30 to 100 times what spinning disk is. However, the capacity and cost of this storage is nowhere in line with what we can get from traditional spinning disks. It's also still a fairly new market. Spinning disk has been around for many years, flash storage only a handful. So hybrid systems that combine flash and disk to deliver the best of both worlds is really the topic of what we're going to talk about today and the focus of Nimble Storage. Some of the other challenges today, just in the general storage market, is meeting this trade-off of performance and capacity. You want fast disk, but you want enough capacity to run your applications. And it's more than just having spinning disk in the environment. You want to be able to protect the data that's on those disks, and things like snapshots and replication become very critical in data center types of applications. Also want to try to reduce the complexity of putting together a flash and disk solution, and reduce the amount of administration required to manage such an environment, making it easier for small to medium businesses and even large enterprises to quickly deploy the technology and easily manage it. This is where Nimble Storage comes in. Our goal is basically to provide a tierless architecture with smart caching and write-optimized layouts to give both read and write improvements. And we'd also introduce the ability for very lightweight snapshots and replication. And our overall universal compression gives us additional performance benefits. This is all wrapped up in what we call the Cache Accelerated Sequential Layout, or Castle architecture, of the Nimble product. We're going to look at this in a little bit more detail. Nimble Storage engineers founded the company and looked at the flash storage solution that they were looking at building. A couple of questions came to mind. Flash in the data center was definitely going to be a critical part of this solution. But the first question was, where do we deploy the flash? Do we put it in the storage architecture or in the server architecture? Trade-offs on both of these, benefits to both. Nimble Storage chose to put the flash technology into the storage layer where it could be shared by all the compute resources in the data center. Once we decided that we were going to use flash in the storage layer, the next decision was how to use that flash solution. Was it going to be a combination of flash and disk, or a flash-only solution? There are vendors out there building both of these. Nimble chose to marry the combination of high-speed flash storage and cost-effective traditional storage into a hybrid solution. Once making that decision, we now had to look at whether we wanted to use flash as an endpoint for the storage architecture, essentially building a tiered solution, or if we wanted to use the flash capabilities of the solid-state drives as an accelerator to the traditional spinning disk. This is what Nimble chose, basically using the flash as a cache accelerator for a more adaptive solution. The decisions weren't done yet. Now that we chose the accelerator or the cache method, building a hybrid solution of flash and traditional disk storage, we then had to decide whether we wanted to enable read cache or use it as a larger write buffer. Which part of the I/O problem were we going to try to tackle with the flash storage? Because of the sequentialized layout of the log structured file system of the Nimble storage, we already were seeing great write performance capabilities. So we chose to use the SSD drives, the flash technology, as a larger caching mechanism. It also gave us a number of other engineering things that we could deal with to better optimize the use of the flash technology. And then the final engineering trade-off here, or decision point, was whether to go after write optimized or read optimized cache layouts. And the sequentialized layout, as I already said, of the write aspect of the storage gave us a clear direction. We would do a write optimized sequentialized layout of a log structured file system on a cache based accelerator of a hybrid storage solution, blending the best of both flash and spinning disk drives. Let's look a little bit more into how these mechanisms work. As hosts send data to the Nimble storage, it's received, stored in NVRAM, acknowledged, and then compressed inline to further reduce the space requirements. This universal compression can save anywhere from 30 to 75% of the storage footprint of the data itself. It also gives us some optimization methods on the cache management. Once we've received a large chunk of inline compressed data, we'll then write that out in large write stripes to the traditional spinning disk. This way we can get optimal performance out of the hard drives that are in the Nimble storage. Then for certain workloads, like random reads or random writes, we're going to also store a copy of that compressed data in the flash cache. And this allows us to have a very quick response time on random I/O workloads, which traditionally are very difficult for spinning disk. Now let's look at using Nimble storage specifically for VMware. Since entering the market, Nimble has always had a strong relationship with VMware. Virtual Center plugin, vStorage API integration, Site Recovery Manager, failover support, and snapshot integration. Let's take a look at Nimble storage for VMware. Since entering the market, Nimble has always had a strong relationship with VMware at the Virtual Center and ESX host levels, with integration with the Virtual Center plugins, vStorage API integration, Site Recovery Manager connections, as well as application and Virtual Center consistent snapshots for improved backup and recovery. Recently, we've also partnered with VMware on their Rapid Desktop program, which basically offers pre-configured, validated VDI solutions on a hardware compatibility list. Think of these as pre-proven POCs. Now let's take a look at Nimble storage itself. Nimble storage out of the box has a very simple initial array setup. The array setup manager basically will query for a name and some IP information and administrator passwords to provide identity of the Nimble storage on the network. From there, you can then manage it directly through the Nimble management user interface, or in some cases through the Nimble CLI with a simple command set. Nimble storage, being basically an iSCSI storage solution, connects to your standard Ethernet environment. Configuring the Nimble storage on your network is a very simple process. Typically, we will have a management interface to the array where you'll see the UI and the CLI, iSCSI discovery and data access for connections to your ESX hosts, and then support interfaces should there be any problems with the other IP connections to the array. On your iSCSI network, we would basically recommend separating management and data networks both on your switches and on the Nimble storage, although they can be on the same network. And we also recommend using round-robin multipathing for ESX or your Microsoft environment. And where possible, all the way from the host through the switch to the Nimble storage, you can enable jumbo frames for greater throughput. So let's look at the logical organization of the Nimble array for just a moment. Just a couple of key concepts and we'll be on our way to configuring storage. The first one is the concept of a performance policy. On Nimble storage, the performance policy identifies essentially the base level block size that we're going to be interfacing to the host with, and whether caching is going to be enabled and compression is going to be enabled. For VMware environments, and particularly for VMware View, using the standard 4K block size is fine, and enabling caching and compression will yield better benefits. This is very easily done through the Management UI, through the Manage Performance Policies interface, where we can simply just name our new performance policy and pick the block size and check compression and caching for this particular performance policy. We'll be using this later in our volume construction. The other thing we'll want to set up early on is the host connectivity information. This essentially identifies the iSCSI initiators in our overall storage infrastructure. Again, from the Management UI, we can simply go to Create Initiator Groups, and we can assign a new initiator group here. For example, I selected Mobile Secure Desktop, and identify the initiator name of the ESX host or hosts in that particular group. We'll come back and use this when we are actually configuring and connecting the storage. The last two things we'll want to look at, and these might have to be done through the CLI depending on the versions you're running, is we can register the Nimble storage and the Virtual Center environment by logging into the Nimble storage CLI and using the VMW plugin command to register the Virtual Center in your environment. Now in this case, the Virtual Center and the Nimble storage need to be on, and the Nimble storage management interface need to be on the same subnet. This will allow us to manage the Nimble storage array from the Virtual Center plugin. On the ESX side, if we want to enable round-robin multipath I/O for all Nimble volumes created, we can very easily set a new SATP ALUA rule for the Nimble storage, and this will basically enable round-robin multipath I/O on all new Nimble storage volumes created, although we could do that manually if we wanted to. Let's spend a moment talking about protecting the data on the Nimble storage. For this, we have the concept of protection templates. Protection templates provide a mechanism for synchronization, snapshot, and replication of Nimble volumes from one array and from one Nimble array to another. They provide a consistent way to manage the overall protection methods that we might deploy in our environment. Again, from the Management UI, we can simply go to Manage Protection Templates, and a screen comes up where we now can create a new name for this protection templates. In this case, we're going to look at VMware View Desktop Protection. We can start with a blank schedule, which will bring up a few more screens where we can now identify the way that we want to synchronize. In this case, we want to synchronize with our VMware vCenter, provide the login credentials to the Virtual Center for this synchronization, and then we'll identify a schedule. In this case, we're going to do a daily schedule that kicks off every night at midnight, typically when users won't be on their View desktops. And we can also define the number of snapshots to retain and whether or not we're going to replicate this. For this example, we are not going to replicate to another Nimble array. We'll be doing local protection of our View desktops. What these storage snapshots then provide is a method for the Nimble array to take automated, synchronized, consistent snapshots with the Virtual Center environment. I also have the ability to basically take manual snapshots, and these snapshots are at the volume collection or at the individual volume level. So in this view here, we can see that I have a combination of manual snapshots and automated daily snapshots running against this particular volume that's in this volume collection. From these snapshots, I can easily recover either the snapshot itself, or I can make a clone of this snapshot for selective recovery of parts of that while the rest of the environment stays intact. Now that we have our performance policies, our protection templates, and our host connectivity, let's look at how we organize the storage on a Nimble array. Through a combination of volume collections and volumes, we'll be able to organize the LUNs on the Nimble array to present to our VMware environment. A volume collection contains one or more volumes with the same management properties. For VMware View, and for a lot of the VMware environment, we actually recommend using a one-to-one mapping of volume collection to volume, and this gives you both a granularity and a collection method for administering the storage on your Nimble array. Creating a volume collection is a very simple task. Again, going back to the management UI, we create a volume collection and give it a name. Here we're going to pick the protection template that we defined earlier, in this case our View desktops. This will automatically bring up the credentials and the method that we had chosen for that protection template, as well as the schedule. And this allows me to make any changes if I want to connect to a different virtual center or have the schedule run at a slightly different time. Once I have my volume collections, I can now create volumes in that volume collection. The volume is where I define the size, the access, and the way that the volume is set up. Now that I have my volume collection created, I can create the volumes. Volumes are typically organized by functional or management characteristics and define the size and access and organization of the pieces of storage in my data center environment. From the management UI, I can simply select Manage Volumes and create a new volume, giving the volume its own name, associating with a performance policy that I've already defined, or if I need to define one here on the fly, I can. I'm going to restrict access to my volume to the initiator group that I defined earlier, and then I'm going to define the size, and here I'm going to set a 50% reserve on our volume. By default, Nimble volumes are thin provisioned, but I can always set aside a reserve storage just to make sure that there's enough storage left in my environment for this particular volume. I'm now going to associate this volume with the volume collection that I've just previously defined. And with that, we're done. We have a Nimble volume now created in a volume collection associated with our ESX server in our virtual center environment, being protected through the virtual center synchronization on a regular basis. A couple of other things to keep in mind when looking at storage from both the Nimble perspective and the VMware side. It's very easy to have a capacity overcommit with all of the thin provisioning, compression, linked clones, and various methods that are available both in the Nimble storage and the VMware environment. If we look at the view, for example, at the properties of a data store in VMware, we can see that a 500 gig volume with a VMFS partition on it shows up just fine. All right. On our Nimble storage, we see it's a 500 gig volume, of which right now we've only thin provisioned a very small amount. We haven't begun building anything in this volume, so its consumption of actual Nimble storage on the array itself is very small. We're also seeing a compression here of 17x. Typically in VMware environments, this compression value will be more like 1.5 once we start populating the volumes with real data. We can also see by looking at the paths on this particular volume, because we've enabled the multipath SATP ALUA rules, that we actually have round-robin access on all 4 of our paths to this volume from the host to the storage. Now let's look a little bit more at using Nimble storage for VMware View VDI. VDI deployments cause an incredible demand on the storage infrastructure under them, often having boot storms or login storms with very high random read requirements. During the workday, the actual workload can be fairly low in just a handful, 5 to 10 IOPS per desktop. And then occasionally there will be what I call operational tasks, AV scans, patches, updates, things being pushed out to the environment, where the write workloads could actually increase. Managing this fluctuation in the storage infrastructure has to be very flexible in adapting to a read and a write intensive workload. What we find with Nimble storage is that the steady state workload is very easy to handle. And even the peaks, several thousands of IOPS required to boot or log in a bunch of machines, is not a problem with the Nimble storage. So boot storms and steady state are easily handled with the read and write workload balancing with the Castle architecture for Nimble storage, where the cache accelerated reads are well balanced with the sequential layout writes, giving a very adaptive and well-balanced storage platform for VMware and VMware VDI. So one of the other observations here, when you're looking at cache-enabled storage, it's not just for the read optimizations. What we're finding is the need for write-optimized storage is just as critical in a VMware environment, and particularly with VMware View VDI solutions. New features in View 5.1, the View Storage Accelerator, or VSA, allows the ESX host to actually do some of the random read operations at the host level. A well-balanced storage architecture for reads and writes is important, but what we're actually finding in VMware View VDI environments is the need for write-optimized storage is just as important for read-optimized cached storage. A note here from Mendel Rosenblum from several years ago highlights the point specifically. By adding more memory into either the server or the storage, we'll be able to satisfy read requests much more readily. What VMware has done with View 5.1 and the View Storage Accelerator, or VSA, is found a way to take a part of the ESX server memory and cache on a content-based method a lot of the highly repetitive random reads coming from the VM workload on that ESX box. What this does for the Nimble storage is it tends to shift the read and write work a little bit. And what we're finding is if the read workload on the Nimble storage or the underlying storage is reduced, then the write workload should be able to increase. The expectation is that if VSA read caching in the ESX servers will shift the workload off, the read workload off of the Nimble storage, we should be able to see the write workload increase. And we see that in lab testing, both with specific testing and with VMware View 5.1 with VSA enabled. In this case, the graph shows the blue line, the top line, where the reads are twice as frequent as the writes, operates at a particular level. If we shift and suddenly write twice as much as we are reading, the total workload shifts down a little bit because write workload's a little bit more intensive, but we are very capable of picking up the additional write overheads as the read workload is reduced. This is exactly what we would expect from the Castle architecture when blended with the View 5.1 VSA solution. So looking back briefly at VDI benefits, obviously the increased performance and density is one of the key factors of blending VMware View and Nimble storage. The result is we can see higher desktop density on a single Nimble appliance. The storage savings come from the inline compression, the thin provisioning, and cloning, both on the Nimble for volume mastering and also through VMware through things like linked clones, realizing huge performance savings. Reference architectures from the Rapid Desktop program and working closely with VMware and our customers and our partners basically make deployment much easier with Nimble solutions. Let's take a moment and take a quick look at the Nimble storage. And today I'll take you through this short video that will show you just how simple and easy it is to use Nimble storage with VMware View VDI solutions. The objective for today is to deploy a new pool of linked clone desktop VMs on Nimble storage. We'll set up the Nimble storage in just 3 basic steps. Provision the storage directly from the Nimble Virtual Center integration, connect this storage to the VMware View pool, and then monitor and protect the storage with Nimble capabilities, again using the Nimble Virtual Center integration. We begin this setup in the Virtual Center using the Nimble Storage Appliance plugin for VMware. In the Virtual Center inventory browser for the VMware Data Center element, we navigate to the Nimble Storage tab for the attached array, and from here we can easily create a new data store from the link in the commands area. The storage configuration information collected by the plugin includes basic items like the name of the volume for the data store, in this case it'll be Nimble for VDI, the host connectivity, or our ESX server that we're attaching to, the volume or data store size, in this case 1 terabyte, and the protection policy that we're going to use. In this case we'll choose the desktop policy, and that will be a nightly schedule. We also have to provide login access information for Virtual Center so that the plugin can perform all of these tasks. The VMware integration will perform the following steps all from the Virtual Center interface. collect the information about the new storage volume and data store, which we've just done, provision the volume on the Nimble storage array, and then present this storage to the ESX host and update Virtual Center. The progress of the storage provisioning can be observed in the Recent Tasks window in Virtual Center. This Virtual Center plugin provides a very simple method for adding Nimble storage to a VMware environment. With the data store creation completed, we can now browse to the specific data store for more information. At this level, the Nimble Virtual Center plugin tab can be used to review details about the Nimble storage volume just added. These details include space utilization, performance, access control, and general volume information. Now let's switch our context and present the new Nimble Storage Data Store to our VMware View VDI configuration. This task is easily done through the View Administrator Management interface to the VDI environment. When creating a new desktop pool, we simply need to select the new data store during the vCenter settings of the data store's configuration. All other View Pool configuration settings are the same. It's also very simple to update existing VMware View pools to point to Nimble Storage data stores by adding the new data store to the vCenter settings. For this particular configuration, we will select the data store Nimble for VDI for the linked clones View Composer disks, and select the previously configured data store Master Replicas for the linked clones Golden Image Base VM. The rest of the View pool settings get set as desired. This completes the VDI storage presentation step. With the new View pool just added, we can now see in the View Administrator dashboard the status changes for the provisioning of the desktop VMs on the newly added Nimble storage. As our final step of setting up the Nimble storage for VMware VDI, let's focus on monitoring and protecting the desktop data store. We can perform these actions from the Virtual Center Inventory Data Store browser using the Nimble plugin. If we look at the performance graphs presented for our new Nimble for VDI volume, we see some initial read and write activity levels already occurring. This is typical of the desktop provisioning process that we just initiated in VMware View. Further inspection of the performance graphs for the templates and the Master Replicas data store show the expected read-only access associated with the desktop provisioning process. We change our focus now to protecting the storage for our VDI environment. Using the Virtual Center integration, we're going to take a manual snapshot of this data store. We'll call this snapshot VDI Checkpoint. The snapshot takes just a moment to create and will now have an additional recovery point for this particular data store. Snapshots can also be automated through volume collection protection policies, like the desktop policy we selected earlier in this video. Here we see the additional snapshot from our nightly schedules. With the snapshots done, we can switch back one more time to the status view of our new Nimble for VDI volume. From this brief video, we can see how easy it is to use Nimble storage in a VMware VDI environment. Just a few simple steps to provision, present, and protect the storage, all directly through the VMware environment. Thank you. Now that we've seen a brief demo of the Nimble storage, let's take a look at the overall storage management aspects. In any data center storage environment, we're going to want to be able to measure and monitor the performance. In a VMware environment, we'd like to do this at the hypervisor and the storage level. Key characteristics like IOPS and latency are going to be important. These can be pulled directly from the performance tabs in Virtual Center, as well as from the Nimble UI Management Console, and even from the Virtual Center plugin for Nimble storage. These will give us insights into the performance and trending and analysis that we'll need to make sure that our storage is performing correctly. As we talked about earlier with VMware View, VDI environments can be somewhat complex in setting up. There's a lot of choices. If we look at the overall storage architecture from the ground up, where in the Nimble environment we've defined our performance policies and our protection templates, we've bound those to volume collections and volumes, presented those as data stores in the VMware environment, and built those into VMware View pools to manage multitudes of desktops, we can see that there's a number of pieces involved here. This is all fairly straightforward, but what this results in is a number of decisions that need to be made during the course of constructing VMware View desktop environments. How the user assignments are going to be handled, how we're going to deal with persistent and user data disks and things like that. And at the end, when constructing the storage solution in some VDI environments, we're going to have options for where we place our persistent disks, our OS disks, the replicas, linked clones, any number of things. And these can get very complicated at times. Our aim with the Nimble storage is to basically reduce this storage complexity, simplifying the overall storage stack from the ground up. So once the volumes are presented, we can then make very simple decisions as we build out our View desktops. So whether we choose dedicated or floating pools, or redirect disks from the operating system or user data, we don't have to worry about things that you would have to deal with if you had only a fixed or tiered technology at hand. If there's no other alternatives, these choices are important. But with Nimble, I can simplify this overall selection process here because I'm going to have a hybrid flash and disk architecture. And this is going to allow me some flexibility in how I allocate things, just assign it all to the Nimble, and the performance will adapt appropriately, so I don't have to target specific tiers. This makes it very simple now to build my View environments or my desktop virtualization environments by just pointing all of the storage components directly at the Nimble and letting the Nimble array adapt as necessary to the performance or capacity needs required. When I'm applying the caching methods here, I can do this at the server or the storage level with VMware View 5.1. The caching benefits from either the server or the storage side with View 5.1 or Nimble Storage can both be applied. Further, I have both server and storage caching available, so I can use the VMware View 5.1 VSA or the Nimble Storage hybrid storage solution to get the performance and capacity needs that I need out of my storage environment. So overall, simplifying storage management, gaining the performance that we need without the design complexity involved in doing a tiered storage solution. Simple layout of volumes, presentation to the VMware environment, and use throughout VMware and VMware View. Very simple with Nimble Storage. The operational complexities involved with many solutions are now removed. We have the ability to quickly provision storage, monitor its behavior, and even protect it with snapshots and replication. This easy management comes through a single pane of glass in the VMware Virtual Center plugin, or where needed, we can dive into the Nimble Management UI or the CLI to get further detailed access. For more information, here are some resources from Nimble Storage for VMware, VMware View, and Nimble Storage as a whole. Thank you for your time.